Next numerical is, I'm writing the question of the next numerical. Very important question. We already did this question, but it's still very important. The question here
Yes, sir.
is they have given x and y coordinates of a particle. The particle is going in some direction, some trajectory like this. We don't know how it is going. But the trajectory
Yes, sir.
of the whole particle is not given. What they are given is at an instant, the x coordinate they are given and the y coordinate they are given in that. Okay. And what they are given about the x coordinate is 3t square. This is the question. 3t square minus 6t is in the x coordinate, and the y coordinate is given as t square. Y coordinate is given as t square minus
Sir, y coordinate is 3 square minus 2t, sir.
t square minus 2t. Yes, this is the y coordinate. So what we
Yes, sir.
have to find out is we have to see which of the options given there may match to our answer. First of all, you have been given x and y. What we have to do is we have to find out the velocities, then we have to find out the acceleration. Then we have to see what to do. Check the options. With the x coordinate,
Yes, sir.
find out x velocity. Is it or not? And
Yes, sir.
the y coordinate, we can find out the y velocity. How do you find x
Yes, sir.
velocity? By differentiating the x coordinate. Okay.
Yes, sir.
Differentiate with respect to t, the x coordinate. What is x coordinate? 3t square minus 6t. You have to differentiate. Similarly, the y
Yes,
coordinate
sir.
will be differentiation of the y coordinate. T
Yes, sir.
minus 2t. This is the y coordinate of velocity. Now, how would we get Vx by differentiating this? What is the differential of 3t square? We know 3 you
Sir,
discard.
3t square, sir.
T square only you have to differentiate. 3 is as it is in the multiplication. T square,
Yes, sir.
what is the derivative of 3 t square?
Sir, 2
2, very good. T power
t power n minus 1, sir, means 2 minus 1, sir.
1. Okay. Minus
Yes.
6 into derivative of t. dt by dt is 1.
Yes, sir.
Okay, so what we finally got is 6t minus 6 we got. This is Vx. Understood?
Yes, sir.
Similarly, we have to find out Vy. What is Vy? If you differentiate this, t square derivative just now you told no? 2t
Yes, sir.
minus 2 into t derivative is 1 no? Just now we did.
Yes, sir.
So what you are getting? 2t minus 2. This is the x coordinate of velocity and y coordinate of velocity. Okay.
Okay, sir.
Now what we have to do? Again we have to differentiate to find out the accelerations. What is the
Yes, sir.
acceleration? Ax and ay. Again you have to differentiate this Vx and not with respect to x, no? We have to differentiate these with respect again time only. Always differential is with respect to time only. Right?
Yes, sir.
So d by dt of Vx. Sorry, I'm writing that.
Yes, sir.
Similarly, d by dt of Vy. What is
Yes,
the
sir.
derivative? You have to see. Derivative of this we have to take. Is it or not?
Yes, sir.
d
Yes, sir.
by dt of what do you have to do?
60 minus 6, sir.
60 minus 6. What would that be? 6 will be just as
Sir,
dt by dt
yes,
is
sir.
1, no?
Yes, sir.
Minus 6 there. 6 doesn't have any derivative, 0. 6 minus 0. Is it or not?
Yes, sir.
Similarly, if you do the second one also, the same thing you will get. 2t minus 2 is there. Second term being a constant doesn't have derivative. The first derivative, first term 2 minus
2,
0.
sir. 2 minus 0, sir.
That's it. So we got ax, ay, vx, vy. First we have to note these things. These are important for us. Now what we have got is vx and vy, ax and ay. What is vx? 60 minus 6. That was our vx. Is it or not? And what was for Vy?
Yes, sir.
2t minus 2. But these are Vx, Vy. We have to find out V. What is V actually? Vx
Yes, sir.
I cap plus Vy j cap. That is called as actual velocity vector. Okay. So
Yes, sir.
in terms of that, if you write 60
Sir, we
minus,
have to keep the arrow compulsory, sir,
then
on the
only,
upside of V, sir.
yeah, then only
Sir,
this becomes
can I use
vector,
your
no?
white screen, sir?
Uh,
Can I use your white screen once, sir?
uh,
Sir,
oh,
this one, sir, this one.
what we have, oh, just why I put this arrow you're asking, no?
Yes, sir.
Because it is a vector, no? It is a vector. So if it is a
Is it
vector,
compulsory, sir?
yeah, yeah, of course. The vectors means we have to put arrow. Then you must get
Yes,
it
sir.
out. Why Vx and Vy don't have any arrows? Because they are components. Because they are components of the
Yes, sir.
velocity. Okay. Is it understood?
Yes.
Along with I cap and j cap, they will become vectors. Understood now? Is
Yes,
it
sir.
understood? Very clear. Huh?
Yes, sir.
So 2t minus 2, when you put j cap, this will also become vector. Totally, finally, this v bar will become vector. That is why this bar is there. Understood? The reason is that.
Yes, sir.
Is it clear? Hmm.
Yes, sir.
Now, now going back to the question and checking. Okay, this is velocity vector. Let us write acceleration vector also. Then we will see the question options. What is the acceleration vector? When we
Yes.
differentiate, what we got is 6 I cap.
6 I cap plus 2 J
J.
cap, sir.
Yes, this is the acceleration vector. Now let us go to the question option A. Acceleration of a particle is 0 at t is equal to 0. Wrong option. Why? At t is equal to 0, is the acceleration 0? No chance. Is it or not?
No,
How do
sir.
we check
No,
that
sir.
also? Is we have to check the modulus of the acceleration. What is the modulus of acceleration? Root over. This is the way we have to check. Ax square plus ay square. What is that answer? Root over 6 square plus 2 square. What is the answer? It's never going to become 0. It's
36 plus 4, sir, means
40.
40, sir.
40, which is non-zero. So first option is wrong option. Okay?
Yes, sir.
Understood till here?
Yes, sir. I will copy this, sir. Wait a minute, sir.
Please copy. So first option anyway went wrong. So first option is not the correct option. Checking the second option. Velocity of particle is 0 at t is equal to 0. Is that correct or not? We have to check. What is the velocity vector which we have got just now? 60 minus 6 I cap plus 2t minus 2 j cap. At t is equal to 0, what will happen to this velocity? Let us check. At t is equal to 0, if you put t is equal to 0, what will happen here? 0
6
minus 6.
zeros.
Is it or not?
Yes, sir.
0. So plus. Similarly, here also 0 minus 2. Is it or not?
Yes, sir.
What is this answer then? Minus.
Minus 6 I cap plus minus 2 J cap, sir. Not equal to 0, sir.
Yeah, this is not 0. Is it or not? We can simply by seeing
Yes.
itself we can say it is non-zero. If we require, we can actually find the magnitude and prove that it is not 0, because magnitude we have to find out.
Yes, sir.
I told you how we have to find out the magnitude. 2 square. So this is again going to become 40. This is also not 0.
I
Second option.
think the option C is correct, sir.
Correct.
Option C is
Very good.
correct, sir.
Option C is absolutely correct, because option C says at t is equal to 1 second, velocity of the particle is 0. Correct, no? Because
Yes, sir.
at t is equal to 1 second, what is wonderfully happening is v bar is equal to 6 minus 6. Is it or not? I cap
Yes, sir.
plus 2 minus 2 j cap. So it is 0 j, 0 I cap plus 0 j cap. So that is 0.
Yes, sir.
It is null vector. This is called as null vector. Remember this. To 0 I cap plus 0 j cap is called as null vector. Okay.
Yes,
So
sir.
we got a null vector which is 0. So C option is correct. Next, velocity and
Yes,
displacement of particle are never 0. Are never 0, that is not correct, no? Just at t is equal to
yes, sir.
1 second, it is becoming 0. Is it or not?
Yes, sir.
So never 0 is not fully correct. Okay. Yeah. Because C option is correct, so D option contradicts it. Understood? So D option is
Yes,
not
sir.
going to be correct. C option is fully correct.
Yes, sir. Yes, sir.
So that is it. That is the answer. Okay. Clear?
Yes, sir.